Previously, we've talked about how igneous and sedimentary rocks were created. The third and final rock that we're going to discuss is metamorphic. Now, in order to understand metamorphic, let's use some past material that we learned on the other two. So let's take molten rock as an example. Let's just say, for argument's sake, that molten or melted rock has reached the Earth's surface and it starts to mix with the cool or cold atmosphere. If that happens, it's going to begin to cool. Now, as it cools, the top layer of that molten rock is going to harden and solidify into extrusive igneous rock. Now, even though the igneous rock is solid, underneath it, where it borders the magma, is still going to be intense heat. That's just pounding and pounding that extrusive igneous. Now, over time, and again, this doesn't mean it's going to happen in hours, doesn't mean it's going to happen in a decade or centuries, but over the course of thousands of years, whether it be more igneous, whether it be sedimentary, some sort of rock layer is going to go and cover that extrusive layer. Now, when the layer is sitting on top of the extrusive igneous, there's going to be pressure created, which is going to squeeze that extrusive igneous together. Now, add on a few more thousand years, we have additional layers that are going to form. Now, as each layer forms, more pressure is being created. We have another layer, we get more pressure. We get an additional layer, there's even more pressure. Now we're at the point when there is such intense pressure mixing with such intense heat coming from the bottom that extrusive igneous rock now begins to change and we get metamorphic rock. So you have to remember that in order to get metamorphic rock, the existing rock has to be changed by intense heat and pressure.